question number 1 says, describe the error in graphing f of x for each function, then graph the function correctly. So if I were doing the problem, I would probably just graph this first, and then second, I'll describe the error. Because if I do it right, then I can actually find the errors. So a couple of things I notice. I notice that this is missing a 1, and those numbers refer to multiplicity. Multiplicity refers to the exponent. So what kind of information can I get? If I have a multiplicity of 1, multiplicity is 1. Class, is this an odd or an even?
Odd.
And what do you do with odds?
Shoot
Shoot through. And with this one right here, this is a even, you kiss. So here's a little hint what you can do. Instead of actually multiplying this out using the box, right, x minus 4 times x plus 1 times x plus 1, because you have 2 of those, right? That's a lot of work. You can kind of just see, well, it's x to the first, and then x to the second. X to the first times x to the second is x to the third. So I know that my graph should actually be cubic. What does that mean? Well, this is an odd, and another odd is like x to the first. So it's a linear, and the big idea is that it starts down, ends up. So it's new knowledge, but go back to something you know. Access your prior knowledge. Okay, so how can I get a graph with a multiplicity of shooting through and a kiss? Well, if I set these using the zero product rule, so this is going to be on your Chapter 5 test, that's why we're reviewing it. What I need to do here is I just set each of these equal to 0. Class, what do you do? Class, what do you do? Send it to 0. Now, isn't that kind of funny that you set the same equation up twice? Do you see that? So if I solve this, x is equal to 4, and there I have my shoot through, and then here x is equal to what? Now, isn't that funny that you kind of have it twice? Do you see that? That's what it means to have a double root, or that's why you have a kiss there, or a bounce. Okay, let's go ahead and graph it. So x equals 4. 1, 2, 3, 4. X equals -1. This is the first one. This is the second one. Class, can you see the second one? No, because that's why it's called a double root. I look above. I recognize that it's an odd. So it's going to start down, end up. So you just draw your arrows. Remember, at the pink, I'm going to have to do a kiss. And then when I get to the blue, I'm going to do a shoot through. Let me go ahead and sketch the graph now. So as I approach the pink, I'm going to do a bounce or a kiss. And again, the reason why is your multiplicity is 2. Another idea is this is called a double root. Then I need to go through the blue. I'm going to shoot through it and end up through that arrow. My graph might look something like that. Okay, so I just graphed the function correctly. Again, recognize that this polynomial is factored in factored form, which means it just has parentheses, therefore you look at its multiplicity. Let's look at the incorrect graph. Question number 1. So here's the incorrect graph. There is, they put a shoot through at -4. Okay, so we can write the error is at there should be an x-intercept at x equals 4, comma, not x equals negative 4. Do you see their mistake? The mistake is they just see the negative 4 and they just put a dot there and they just graph it. And they ignore the zero product rule. That's why it turns into a positive. Over here, same thing. Here they have an x equals 1 because they see a 1 there. This is wrong, right? The hint is it tells you to describe the error, so this is wrong. At 1, we should set it, the zero product rule, we should set it equal to 0, and you'll get x equals negative 1 should be your bounds. Their end behavior is correct. It's just their x-intercepts.